Okay, we're at Camp Miakonda, April 9th, 2013. We're at the downstream end of Hartman Ditch between the three-sided culvert, and there's a round culvert upstream. This is head cut down probably 1.5 feet, maybe a little bit more, so you can see that this bank's eroded all the way down through here, all the way up around the bend. There's a couple of head cuts. We're going to look at that in a minute. If you look over toward the three-sided culvert, this is a D stone, a D-sized stone. There's bank protection in here, and you can see that the lower section has launched into the stream, which is how it's designed to do. So when that bed lowers down, then the rock self-adjusts into that scour hole. Now, the head cuts have come from upstream. The culvert does not have a bottom on it, so we're going to have to put a engineered rock riffle or a check dam right there at the upstream side of that three-sided culvert. Coming around here, we need to key in this bank protection right through here, so we're going to dig back up in here, take some of this stone and place it in there. We'll put some dogwoods, maybe some willows if we can cut those. We'll have protection on this key at the upstream of that bank protection. And then at every one of these stakes coming through here, we'll have a bendway weir. So it'll probably be about 2 foot long. It's going to be angled upstream 70 degrees from the bank, flat, level crested, probably 3 or 4 inches above this flow that we got right now. Maybe a little bit more than that, because we're going to have to, that engineered rock riffle is going to fill that in. And then each one of these is going to be keyed in. Okay, so we're upstream a little bit more. We've reduced our spacing in here on our bendway weirs, and these are only 10 foot apart because of upstream attack angle coming in here. We didn't want the flow to come in and miss both of these bendway weirs. So a little bit closer on our spacing. Coming up around here, we've got 12 foot between these. You can see that this whole area right in here is slumped and fallen in, so we need to stabilize that. Coming up around here a little bit, you can see looking upstream that we've got a really good 2-stage head cut in here, and you can see how much of that's dropped. You can probably also hear that noise. So that's our head cut. It's active. It'll keep on moving all the way up to the culvert. We need to stabilize almost all of that. We're going to put in a grade control structure right here. So this bendway weir, this key and this bendway weir will be part of this grade control structure. It'll also go all the way across the creek and go up the other side and tie into that bank on that other side. And what it's designed to do, raise the water surface elevation, the bed of the stream will fill in. And what I want it to do, when you look at the sand that's right up over here, on the higher flows, I want this water coming down here to slow down with that grade control structure. And then I want that water to jump out, go into this section of our floodplain bench, which is our wetland. So when this stream digs itself down, foot and a half, that's lowered the water table. That's going to dry out our wetland. We need to bring that water table back up with the grade control structures. There's going to be at least 2, maybe 3. And then we want to sheet flow, level spread this water out into that floodplain, out into that wetland during those high flow events. That's a way that we're going to keep our wetland wet and keep it working, and those plants that should be in there, get those to grow and function. Okay, standing next to the head cut, Matt's walking up through the stream. You can see that we've got roots that have been exposed, so you can see that this river has dug itself down. Typically, when the bed of the stream digs down, it's a 5-to-1 ratio, maybe up to 22-to-1. So if it digs down 1 foot, it'll go anywhere from 5 to 22 foot wider. We definitely don't want that to happen. This stream will be 2 to 3 times the width in here, and that's not what we want. So we need to bring that stream back up, bring the bed of that stream back up, bring that water table back up, and reconnect this stream with its historic floodplain, which is our engineered wetland. Okay, we've moved upstream a little bit. You can still hear and see that head cut that's coming up through here. We're in a little bit of a straight stretch right here. We're not going to have a whole bunch of stone. We're stealing stone off a pile of stone. So the bendway weir is going to be farther apart because this is a straight stretch. And then coming around this bend, we want to, you can see how vertical this thing is. This thing's straight up and down, all fresh cut. All the roots are exposed in here. We'll have a bendway weir in here that will redirect that flow, kind of take it past this little bit of an elbow. We've got a straight stretch and a straight stretch here. And then upstream, you can see in that really, really tight bend where the large tree is, we're extremely undercut, vertical, probably dug down 2 foot, a whole bunch of roots exposed. We're going to come in there with some of the smaller D stone, and we'll do a longitudinal peak stone toe protection, which is a triangular cross section of stone. We'll put that in, we'll key on both ends, and then we'll put some of our willows and dogwoods back behind that, and then we'll collapse that bank on that, which will plant those plants, and then that slope bank will be stable and we can vegetate that bank. It'll be real similar to what we did on the floodplain benches on the Ottawa River at reaches 1 and 3 right here at Miakonda. Straight stretch, we're probably 60 foot or so from that really bad looking bend that was head cut. And obviously this area has not head cut. So when we look up here at this culvert, probably a 36-inch concrete culvert, it's 2/3 filled. And it's been like that ever since we started looking at this project about 3 years ago. So that hasn't changed. We would like to change that. So we're gonna stop part of that head cut from coming up here, but we wanna let some of the rest of that head cut come up and basically clean out that culvert for us. That culvert's the only bottom that we've got in this system until you go way further upstream, probably another 1,000 foot upstream. So this section in here, we really want this to head cut, probably 1.5 feet or so. Come up here, clean out our culvert, which has been a problem for forever, and then that'll take care of that problem. And but we still need to stabilize everything downstream.
have invented